Good evening, everyone. In the last session of 8051, we had discussion on on the brief idea about our syllabus. So first, we will start with the 8051 microcontroller. After that, we will discuss ARM controller. After that, we will discuss CAN protocol. After that, RTOS. So that will be our flow. First 8051, second ARM controller, third CAN protocol, and fourth RTOS. So this is our execution flow. So in this order only I will take the class. So today onwards we are going to start with our practical session. So practical means actually some technical concept we will start. In the last session we discussed about future scope of our vector course, and we discussed a brief idea about each module. So today our point of discussion is about microprocessor and microcontroller. So we will discuss what is the microprocessor, what is microcontroller, what is the difference between microprocessor and controller, and what are their IC numbers. So that point we are going to discuss today. Okay, so as everyone knows, like in the academics, you learned already about the microprocessor, and I think CSC students are also having one. You will get you know something about the processor. Okay, but come to the electronics branch. Electronics student used to program that microprocessor and program that microcontroller directly. Okay, so very low level program we used to do, and CSC student used to write languages like C language, C++, Java language, and they used to do programming on high level in the operating system. But electronic students used to write very low level programming like assembly program and embedded C program for microprocessor and microcontroller. But in the today's date, microprocessors are not used in the embedded system. Today's date, microprocessors are not used in the embedded system. So today's date only microcontrollers are used in an embedded system, because when the microprocessor is used in the embedded system, that increases cost of that microcontroller. That increases the cost of the project. That increases the hardware complexity of the project, and that increases the program complexity also. That's the reason microprocessors are not used in the embedded system in the today's date. So only microcontrollers are used in an embedded system. Only microcontrollers are used in a embedded system. Like let's discuss about embedded system also. In the first class, Guru sir already told you what is meaning of embedded system. So this embedded system is combination of hardware and software designed for a specific task. So you can write embedded system is a combination of hardware and software designed to perform a specific task. Designed to perform a specific task. Embedded system is a combination of hardware and software designed to perform a specific task. That is what is the embedded system. Okay, what are the electronics gadgets you see in the market? Like for electronic students, it is very easy to explain what is the embedded system because that already they learned already for 4 years their engineering, and if you have done the diploma, then you have learned this embedded system for 6 years. But for CSC student, it is very difficult to explain about embedded system. But in a simple way, remember the simple way to understand what is embedded system is any electronic system, any electronic system except computer and laptop is embedded system. Any electronic system except computer and laptop is embedded system. So except computer and laptop, we have mobile phone that is called as embedded system. We have smartwatch that is embedded system. We have a digital watch that is embedded system. In the AC also there are something electronic part is included. We use remote control and we used to control. We used to actually control that AC operations with the help of remote control. So there also electronics something included. That is also called as an embedded system. Then electronic toys. What are the electronic toys we are getting in the market? So that is also an example of embedded system. Washing machine. So first we set the program. First we set program in the washing machine, and washing machine will take care of washing the clothes. So there is a program, right? Fuzzy logic, then hard cloths, soft cloths, the woolen cloths. Then there are some programs are there in the washing machine. Okay. So before you start the washing machine, first you have to select that program. Okay. So that selection panel you see, right? There will be like buttons will be there on the selection as a selection panel. On the washing machine, there will be buttons will be there, right? So with the help of those buttons, we used to control, we used to select that operation, we used to start the washing machine. So whatever that control panel is there, right? Electronic control panel, that is nothing but an electronics control panel, we call it as. So that electronic control panel is called as an embedded system. Make sure that complete washing machine is not an embedded system, because washing machine is a combination of mechanical work and embedded electronics also. Mechanical work and electronics. So inside washing machine, there will be a big motor will be there. That motor will be rotating so that your clothes will get washed. So next, it will be like some other mechanical arrangement will be there inside the washing machine. And other side, like how much time it has to rotate, how much time it has to take, how much water it has to intake, then how much time it has to wash, how much time it has to rinse. That complete logic is taken care by the embedded system. That complete logic is taken care by the embedded system. Okay, so complete washing machine completely not a embedded system. So washing machine is a combination of mechanical work, electronics work, and electric work. Electronics, electric, and mechanical work, like that. Another example is complete AC. Like if you are air cooling system, the complete AC is not an example of embedded system. In that AC, which we used to turn on the AC, we used to turn off the AC. On the remote control, we press the button, right? So we turn on the AC, we turn off the AC, we increase the temperature, decrease the temperature. So we move that panel. So that actually that controlling that part is there, right? That is a example of embedded system. So inside the AC also some mechanical things are there, right? Without using the AC also, like without using the remote control, without having that control panel also, AC will run. AC will work without using that remote control and panel, right? So the only thing you have to switch on the AC, that's it. So once you switch on the AC, there are some mechanical part is there, some electric work is there, some electronic work is there that will take care of this cooling system. Okay, so that is what is the embedded system. So embedded system can be a small part in a big mechanical machine. Embedded system is a small part in a big mechanic system. Example, AC and washing machine. So embedded system, like it will be like combination of this only, like hardware and software. Okay. So like suppose let us take an example of simple embedded system. Let us take an example of simple embedded system. Let us take example of digital clock. Let us take an example of digital clock. This is one of the embedded systems. So you can say wristwatch, or you can say it's a wall clock. Digital clock can be a wristwatch, or it can be a wall clock. Let us take example of digital. This is a wristwatch. Digital clock is the wristwatch. So we are getting right digital clocks in the market. So we have like many like brand like a Sonata company is there, then G-Shock company. These are digital clocks, right? You're coming into the market. And now in the digital clock, what will be there? You will be having one display. You will have one display in the digital clock. You will have one display in the digital clock. Obviously, one microcontroller will be used, that is hardware. And microcontroller and this display is connected. Microcontroller and display is connected. And there are some switches will be there on the digital clock, right? 1 or 2 or 3 switches will be there on the digital clock. I will write only switches. Instead of showing like 2-3 switches, I will write only switches. Then you will have microcontroller. You will have microcontroller inside the digital clock. You will have microcontroller inside the digital clock. You will have display inside on the digital clock. You have switches, and you have there is one more important unit in the digital clock is the time and date. Time and date actually taken from a real-time clock. There is something called as a RTC. Inside the digital clock, the time and date is taken from real-time clock. It is, in short, it is called as a RTC. In short, it is called as a RTC. So this is your digital clock mechanism. So on the display, it will display hours, minutes, seconds, AM, PM. Then it will display date, month, and year. So it will display day also, like what day it is: Sunday, Monday, Tuesday, Wednesday. So nowadays in the digital clocks, they have added something sensors also, step counter, and like a heartbeat monitor sensor. So that type of sensors nowadays they have added into digital clock. So let us not talk about that smartwatch. Let us not talk about the smartwatch. We will only talk about that digital clock, simple clock. We will talk about that digital clock, simple clock. Okay. So this digital clock will have this type of mechanism. So it will have microcontroller, it will have display, it will have switches, and it will have real-time clock. Okay, like displays, like it will display time and date. Switches are used to adjust the time and date. Suppose if you want to set time and date in your digital clock, these switches are used. So switches are also connected to microcontroller. Then there is one more important unit in the digital clock is real-time clock, RTC, real-time clock. So this real-time clock is an IC. This real-time clock is an IC. Real-time clock is an IC. It is integrated circuit. Okay, like as you are from electronics background, electrical background, you should know what is an IC. It is integrated circuit. It is an integrated circuit that we call it as an IC. So computer science student, we used to call it as a chip. That is called as a chip. Okay. So this real-time clock is an IC which gives the time and date to the microcontroller. When microcontroller wants to display time and date, so then this microcontroller will read time and date from the real-time clock. Okay, here is the main heart of this system. Main heart of this system is the microcontroller. Main heart of the system is the microcontroller. This is what is called as an embedded system. This is what is called as an embedded system, and it is designed for the specific task, designed for doing the specific task. Like what this system is doing, it is reading the time, it is displaying the time. And when you want to set the time, that time setting can be done with the help of switches. Okay, so this is what is called as a specific task. This is called as a performing a specific task. Read the time and display the time. That's it. That is what is called as a specific. This is designed to perform a specific task. So main heart of this embedded system is the microcontroller. Main heart of the embedded system is the microcontroller over here. In your computer, the main heart of the computer is the microprocessor. If you remove processor from the motherboard, nothing is going to work, right? Because processor is the one which is actually executing your OS program, which is executing the OS program. OS is a big program. OS is a big piece of program, or it is a big piece of code. And that program or that code is executed by the microprocessor. And if microprocessor is not available on the motherboard, then who is going to execute that program? Hope you see my point. If you remove microprocessor from the motherboard, your computer won't start. That is the same. That is called as the heart of your computer system. So here, the heart of the embedded system is the microcontroller. Heart of embedded system is microcontroller. If there is no microcontroller, nothing will work here. If there is no microcontroller, or if you remove microcontroller from here, nothing will work here. Because microcontroller is the one here. What is the role of microcontroller is? Microcontroller is the one which will read time and date from the RTC, So reading time and date from the RTC is taken care by the microcontroller. So read time and date from the RTC, and it will display this, or it will print this time and date on the display. First, it will read time and date from the RTC, and then it will print this time and date on the LCD, or it will print time and date on the display. So it will read it and it will store it into the array, or it will store it into variable. It will read the time, and after reading the time, then microcontroller will store time and date into variables that we call it as a buffer. Technically, we call it as a buffer. So it will read the time, it will store it into buffer, and after that, the microcontroller will display, or it will print the time from the buffer. So whatever there in the buffer, it will print it on the display. So that is the role of microcontroller. If there is no microcontroller, then who is going to read the time, and who is going to display the time? So make sure that there must be a microcontroller in between to read RTC time and to display it. So RTC is not intelligent. RTC is not intelligent to directly give data to display. RTC is not intelligent to give the data directly to display. And display is not intelligent, which will read data from the RTC automatically and print it on the LCD screen. So these two devices, display and this RTC, both are not intelligent devices. If they are intelligent, then the cost of this device will increase. If these are intelligent, RTC is intelligent and display is intelligent enough to read from the RTC and display it automatically, so then the cost of these devices will increase. So if you are going to buy this RTC, it will come in less than 100 rupees. If you are going to buy this RTC in the market, it will come in less than 100 rupees. Just imagine you are getting digital clock in 200, 300 rupees. Just imagine what is the cost of RTC, what is the cost of microcontroller, and what is the cost of display. Hope you see my point. Okay. If you're going and if you're buying that duplicate watch, like in 150 rupees, 200 rupees, 100 rupees also, you will get the digital watch. And for kids watch also, like it will be like 100 rupees, like in the less than 100 rupees, you're getting the digital watch for kids. So just imagine there is a kids watch also, there will be an RTC, there will be a microcontroller, and there will be a display. Okay. So all these things are coming in very less price. So like if you're buying very good quality digital watch, so you will get in 1,000 rupees or 2,000 rupees, not more than 2,000 rupees. Very good quality on branded digital watch. You can buy it in like less than 2,000 rupees. Just imagine in less than 2,000 rupees, you will get display, you will get microcontroller, you will get the RTC, you will get switches, all this mechanism you will get on the digital watch or digital clock or wristwatch, you can say. So, and whenever you buy this digital watch, so like you have to replace that battery. There will be a battery also will be there, right? So microcontroller will take the voltage backup from the battery only. So the microcontroller will take the voltage backup from the battery only. So that battery backup will last for 2 years or 3 years also. If you are using any digital watch, so you should be knowing that one. So that battery, whatever the battery we use for digital watch, that will last for 1 year, 2 years also. So in 1 year or 2 years, you have to change the battery, and that battery cost will not be more than 100 rupees. The battery cost will not be more than 100 rupees. Okay, you see that point. So in 2 years, your maintenance is only 100 rupees. In 2 years, your maintenance is just 100 rupees. So product cost will be like 1,000 or 2,000, and yearly maintenance will be like only 100 rupees. So this is what is called as an embedded system. So now if you're going for computer and laptop, so computer and laptop needs 230-volt AC. So continuously we have to give 230-volt AC if you are using a desktop. So laptop has some battery backup. So when the battery backup is over, again you have to recharge this battery, right? So then in the laptop also battery backup won't be more than 7 hours. It won't be more than 7 hours or 8 hours, right? It will be last for like 7 hours or 8 hours without connecting Bluetooth, without connecting Wi-Fi, without connecting internet. So you can use this laptop for like at least for 5 or 6 hours or 7 hours. The company will promise that 7 hours, but it will not. In practical, it will not come as a 7 hours battery backup. Okay. So this is what is the embedded system. In the embedded system, your power consumption will be less in the embedded system. Power consumption will be less in an embedded system. See, once you connect the battery to this digital clock, it will last for 1 year or 2 years or 3 years also. So you can see the power consumption is very, very less in the digital clock. Next point is it is designed to perform a specific task. See, display the time and date. That's it. Display time and date. And in the case if you want to change the time and date, if you want to set the time and date, we use the switches. So that only performing the specific task. Another thing, like if you can compare with the computer and desktop desktop and laptop is inside this digital clock you will not have the operating system. Inside this digital clock you will not get the operating system. So this is an OS-less device. Inside this digital clock you don't have the operating system. Nowadays in the smartwatch we are getting an operating system, and if you get operating system in the smartwatch, so you know the cost of that smartwatch. It will not be less than 3,000 rupees. It will not be less than 3,000 rupees. But digital watch you will get in like 200, 300, less than 1,000 rupees also, or 2,000 rupees also. Not more than 3,000 rupees. Okay. So that is what is an embedded system. Now, what is the role of programmer here, embedded engineer here? Why embedded engineer is required? Like microcontroller is reading the time, microcontroller is displaying the time. So if I do engineering, then what is my role in the digital clock project? What is my role in the digital clock project? What is my role in the digital clock project? Anyone knows that? See, I did engineering. I have BE degree or ME degree. Okay, so what is my role in the digital clock project? Yeah, N2 you are right. N1 also you are right. T1 you are right. So what is the see? Microcontroller is reading from RTC. It is displaying on the display. It is printing the time on the display, right? N2, okay. Program and perform task, okay. K5 you are right. K5 you are right. Okay. Yeah, S1 you are right. S11 you are right. K8 you are right. Yeah, S4 you are right. Yeah. So almost all like most of the students in this batch is from electronic background, and most of the students are able to answer it. Okay. So the role of this engineer, like if I do engineering, and if I get into the company who is designing this digital watch, like suppose you get a chance to work in a Casio company, and you got placed as a embedded engineer. Assume that embedded engineer or firmware engineer. Embedded engineer, firmware engineer is same position only. Okay. So once you get into the company, like what kind of role you will get in that company? So you will get a role to write a program. You will get a role to write a program. Okay, so I think another another 10 years, like for next 10 years, uh, very most of the engineer they won't be knowing. Okay, most of the electronics engineer they won't know there is we should do programming in the company. As a if I actually if I pass out the degree, if I get a degree, B degree or ME degree, so when I get into the company, I should do the programming. So very few people, like 5 or 10% people, they won't know there will be a programming also. Okay, when we are learning, there will be not know that there is a programming. But after 10 years, everyone will learn the programming. So like now you might have seen that advertisement on social medias. In the social media, they are giving White Hat Junior, like coding for 6 years, 6 year kids. So now 6 year kids are also learning the programming. Okay, so maybe after 10 years, everyone will do the programming. So if 6 year kids, if they started doing the programming, just imagine what will be the use of this engineering degree. So in the today's date, engineers are doing the programming. But if the kids are started doing the programming from their age of 6, so till the age of 20, they will become master blaster in the programming if they do it properly. If they do it properly, okay. That is one of the very terrific advertising. That is actually true now. Like we usually like thought, okay, that would be good actually. Now the today's date, these kids are very sharp. Like 1 or 2 years, 1 year after 1 year only, these kids knows how to operate the mobile phone, smartphone. So they can learn the programming languages like that. The people thought it, okay, but actually like don't know like whether 6 year kid how he can understand about the programming. And I have seen the actually some other side of this site, those who are teaching programming to the small kids, that actually saw that one, like though the trainers which they are training these students, they are itself not having the proper knowledge. So I saw one video on the internet. So the kid was the one of the kid, his father was an engineer, so his father was a programmer. Okay, so he asked the same question in the first class. That trainer is saying low language, high level language, low level language. He was trying to do something. He was trying to explain something to the kid. So obviously that kid won't ask the question, right? What is the difference between low level language and high level language? Even though the trainer answer, he cannot understand that point. But that kid father asked the question, what is difference between low level language and high level language? So then she was not able to answer it properly. So then he said, if you don't know the difference between low level and high level, then what kind of programming you are going to teach to my kid? See, that actually like from the reputed, that is actually from White Hat Junior only this video was leaked. And now suppose if I sit with my kid, so whatever the trainer is teaching, if I ask some question, I will come to know whether that trainer is having the knowledge or not. Okay, so because I also know the programming, I also know the what is low level language, high level language. Okay, so this will happen. So like after few years, this will start. So you no need to worry about your future. Okay, your future is bright only if you concentrate very well here. Okay, so like for 10 years, 20 years, it will go like that only. So you have to upgrade yourself again and again. Upgrade yourself. Don't stop learning. Do not stop learning. If you want to compete if you want to compete with the real-time world, you should not stop learning. And very soon, like people are talking about this artificial intelligence and all these things. Very soon it will come into the market. It is already there in the market, but don't stop learning. Okay, this is the basic actually we are teaching over here. So your programming base we will create here. So later on, after completing the vector, once you get into the company, so this knowledge will help you to grab the high level knowledge, or it will help you to understand the high level logic. Okay. Now come to our point. So if I do engineering, if I get into the company who's designing the digital clock, so what will be my role in the company? If I get placed as a firmware engineer, or if I get placed as a embedded engineer, so my role will be programmer. I will write the program. Now the question is where we will write the program. Where is the place to write the program? So I will write the program for microcontroller. I will write a program for microcontroller. So microcontroller is a small computer. Microcontroller is a small computer without operating system. Microcontroller is a small computer without operating system. So It is possible to write a program for microcontroller, and that program will execute without OS environment, without having operating system. That program will work in the microcontroller. Isn't it amazing, CSC students? So inside microcontroller is a small computer. It is not having the ability like this desktop PC and laptops. This computer, small computer, has no ability like desktop computers and laptops. Desktop computers and laptops are very very fast. Like they are actually like a million times faster than this microcontroller. So you cannot compete this microcontroller with the computer. Okay, so it's a small computer without an operating system, and you can write a program which will execute inside the microcontroller. Okay, now I can write a program, but why I will write the program? Okay, now you have to write a program. You have to write a program to read time and date from the RTC. So actually, microcontroller will not read time and date from the RTC automatically. You have to write a program. There is a program inside microcontroller. There is a program inside microcontroller. That program will read time and date from the RTC, and that program will display. It will print the time and date on the display. So there is a program inside the microcontroller which is going to read time and date from this RTC, and which is going to print this time and date on the display. So this programming can be done in the assembly language as well as in the embedded C also. You can do this programming in assembly language and embedded C. But nowadays, every company is using embedded C for project development because project development becomes faster. Project development becomes fast. Okay. So like every every embedded system, you will get a microcontroller, and your role will be writing a program for microcontroller. Your role will be writing a program for microcontroller. Example, let us take example of traffic control system. The traffic control system will display green light, it will display red light, it will blink orange light. So they actually, how it is displaying, like what is behind that one? What is behind that one? Sometimes it will display the green signal, sometimes it will display the red light. Actually, I will call it as a light only. Okay. So it will display the red light, it will blink the orange light. Orange light will be never on, it will be always blinking. It will be always blinking. If the orange light is continuously on, that means something programming mistake. There is something programming mistake. Okay, there is a bug in that system. So now displaying the green light, displaying the red light, and blinking the orange light. So behind that scene, there will be a microcontroller. There is a microcontroller, and inside microcontroller there is a program which will display green light, which will display red light, which will blink the orange light. The complete program is written inside the microcontroller. The traffic control signal is also an example of embedded system. And traffic control system, that is the major project. Like some students, they will do this major project in their BTech. Okay. So this is about this one, embedded. Okay, guys, just concentrate here. I got a call from placement team. Just a minute. I'll come back in just a minute. Sorry guys, it was urgent call. It is regarding placement. Actually, they're actually getting continuous companies, but syllabus is not completed. So it is, that's what it is happening. Okay, so in the companies, when you get placed as an embedded engineer, or if you get placed as a firmware engineer, you will be doing a programming. You will be doing microcontroller programming. You will do microcontroller programming in the company. Okay, now my suggestion is, okay, hope you got this idea. Inside microcontroller, there is a program, and program is written by the engineer. So that could be like electronics engineer, electrical engineer, or computer science engineer. It is not like computer science engineer cannot write program for microcontroller. It is not like that. Okay, so you computer science students also can write a program for microcontroller. If you understand this thing, see, no need to understand the hardware part. No need to understand the hardware part. It is like getting time and date from the RTC. So you have to understand what is the behavior of this RTC. So how this RTC is giving the time, in which format it is giving the time. If you understand that one, you will have functions. So with the help of that function, you have to read time and date. That's it. You have to read time and date, and there will be a function to print time and date on the LCD. So if you want to print it on the display, there are functions. So for reading also functions, for displaying on the function. So the only thing you have to understand, like little bit information you should know. You should know a little bit information about this RTC. So in which format it is giving the output. If you know that one, like computer science, not only computer science students, mechanical engineering students also can write this type of programming. Okay. So this mechanical engineer won't actually look into this side. So we had one student in actually 3 to 4 years before, we had one student from mechanical branch. So he used to code better than electronics students. He used to code, like he was very much interested in the embedded side, but actually I don't know, accidentally he went to mechanical side, but he was actually very much interested in the embedded. He came here, he completed the course, again he went back, and you won't believe it, he was studying in second year only. He dropped one semester to complete the course. So that's what that is what one student. So just for knowledge purpose he came here, not for placement purpose, or not for anything. So he gained the knowledge, he did number of several projects, and he completed and he went away. Okay. Now, what is my suggestion is, like, if you get into company as a embedded engineer, suppose if you got placed as an embedded engineer or firmware engineer, I will say embedded engineer or firmware engineer, FE, firmware engineer. If you got placed as an embedded engineer or firmware engineer, after a few years, my suggestion is you switch to device drivers. After a few years, you switch to device driver domain. Okay, the next level of firmware engineering, the next engineer or firmware engineer, or next position for embedded engineer is device driver only. Okay, and for firmware engineer, if you want to work as an embedded engineer or firmware engineer, so you need this knowledge. You need a detailed knowledge of C language. You need a detailed knowledge of C language. You need a detailed knowledge of microcontroller. You need a detailed knowledge of that's it for microcontroller and C language. And protocols. Protocols are important. If you are working as a embedded engineer in the company, knowledge of C language, knowledge of microcontroller, and knowledge of protocol is important. So suppose if you get into the if you want to work as a device driver engineer, if you want to work as a device driver developer, device driver testing engineer, then you need a knowledge of C language, detailed knowledge of C language, detailed knowledge of microcontroller, detailed knowledge of protocols, and detailed knowledge of Linux programming. Detailed knowledge of Linux programming for device drivers. Okay, so don't I'm not like telling you like that. You can directly join as a device driver. If you get a chance in the device driver company, you directly join as a device driver. There is no problem at all. If you have this knowledge, C language knowledge, microcontroller knowledge, protocol knowledge, Linux programming knowledge, you can work into the device driver company. If you can work into the device driver domain, it is not that difficult. Okay. So the next stage of firmware engineer or next stage of embedded engineer would be the device driver. My suggestion is, like, you have to look for the device driver, and don't bother, like, it will be very difficult. So I have worked for 5 years. Let us assume that you got 5 years of experience in the embedded engineer. You got a 5 years of experience as an embedded engineer. Now you're thinking, now how can I switch to device driver domain? What will be my security if I get into device driver domain? If I could not do it, so whether company will fire me or not? Don't think in that way. Don't think in that way. I will tell you, like one of my friend, he actually worked as an embedded engineer for 5 to 6 years in the company. He worked into embedded company for 5 to 6 years. So from his life, from his career, he spent 3 years. He spent 3 years in a small scale industry. So he started his career from 5,000 rupees. It was in my city, like it is in the Maharashtra Sangli city. There was a small scale industry. So he started his career from that small scale industry. So with 5,000 salary. So after 3 years also he was getting 20,000 salary, 20K salary in that place. After that he decided to go to the city, like Pune like city. So where is a big IT hub. So he went there and he joined one of the embedded company and he got very good package, like a 5 lakh or 6 lakh package he got it. So after 5 years, what he did is like he did 1 year, like after 3 years, he completed 2 years in that company, that XYZ company, and he applied for LG company and Sasken company. After completing that 5 years of experience, we applied for LG company and Sasken company. So LG said we will give like 7.3 lakh package, and Sasken company said we will give you 8.3. But LG said, okay, location is Pune. You have to work in the Pune. And Sasken said location is Bangalore. So Bangalore location, obviously, like you will get some more package in the Bangalore location because cost of living is more. It is not like that. Almost Pune, Bangalore, almost same. Pune, Bangalore, Mumbai, Delhi, all same. All same. Like not, it is not like that. Don't compare the cost of living here. So it is almost same. So he actually called me and asked me like, how is the Bangalore? Like, how is the like whether I can be able to do it or not? I said, come to Bangalore. But actually, whatever the Sasken actually offered, they offered device driver position for that my friend, and here they offered as an embedded engineer only. Here they offer embedded engineer only. So because of the package, he selected device driver position. He asked me what is the device driver. He asked me what is the device driver. I said there is something called as a Linux. What you learn that is the same, but there is the add-on is Linux. Add-on is Linux. So believe me, he was not knowing anything about the Linux. First time in his life, he actually come and he saw the Linux operating system in the Sasken only in the Bangalore. After completing 5 years of experience in the as an embedded engineer and firmware engineer, he actually first time he saw the Linux operating system in the Sasken company. And you won't believe it, like when they come to Sasken company send him to the Intel. So there is an audio device driver project actually done in the Intel. So he went to Intel. He worked as that is the client actually. Sasken client is Intel. It was actually. So he went to Intel and he completed here. He completed that project in the Sasken. So you won't believe it. Like after 1 year, he switched to another company, and you won't believe it. So currently his package is around 15 lakhs. Currently his package is around 15 lakhs. Just imagine, he started his career with the 5K. Started his career with the 5K before 6 years. Now he is at 15 lakhs. Just imagine, more than 1 lakh per month. So like this is what will happen. Now suppose Sasken knows that this guy don't have the knowledge of Linux. Then also why Sasken hired that guy? Why Sasken hired that engineer? Because he knows C language, he knows microcontroller, he knows protocol. So he don't know the Linux, but programming is almost same. If you know the Linux, then why you cannot work into device driver domain? Hope you see my point. Okay. So after a few years, you blindly switch to device driver domain. It is not like that. Yeah, actually, C++, what happened is very few companies actually they work on embedded C++. Very few companies they are working on C++ in an embedded system. Okay, not in the companies. Okay, not in the IT companies. IT companies like almost like we can say 40-50% companies are working on C++. But in an embedded system, around 90% companies are working on C language only. So like 10% here and there, they are working on C++. Okay. So in our vector, what are the companies are coming in 1 year. In a 1 year, one or two companies they used to actually ask for embedded C++. One or two company in 1 year. So remaining time, all they will ask C language only if they want to hire as a embedded engineer. Okay. Okay. Which position has a higher demand? So like CEO has a higher demand. Okay, so you can try for CEO that one. See, like it is not like that. Higher demand and all. There are positions, right? Developer. Then after developer, what is the next stage? There is a team leader. So after team leader, you after few years you will become a manager. You will become a manager. Manager will get more salary but less programming interaction. More salary and I said CEO. That is the owner of the company. I said CEO. That is owner of the company. Okay, so it is not like that. It is not like that. So there are some there are some other positions are there like an architect engineer. Architect engineers are there that actually they deals with the projects. They deals with the project. That architect engineer, what he will do is uh, he used to talk to the client. Okay, so like client will be like, suppose you are working as an architect engineer right now, and client is from Japan. Let us say client is from Japan. So it is a Japan-based company, and they're having one project. So what they will do is these guys will explain the project to this architect engineer. This guy will explain project to this architect engineer. Architect engineer will inform this to their team members, and team members will start doing the project. If the project is completed within a given time, so this architect engineer will be knowing how much time it will take to complete the project, and how many resources are required, how many engineers are required, what is the budget of that project. Everything is decided by this architect engineer. Okay, so then this architect engineer will tell this guy, so we will complete this project in a this much time. We will complete this project in a this much time. So this guy will believe him. So after that time, if the project is delivered successfully, suppose this guy has given 4 months of time to finish the project. Suppose if the project is completed in 4 months and if it is delivered, if it is handed over to this client, so the client will get happy. The client will become happy and client will actually give the another project to this company. So now the client will see this person only, whatever the name of this person XYZ, he will see this person only because this person promised this project can be completed within 4 months, and he actually stood up to his promise. So he completed project and delivered into the given time. So next time the client will also check, okay, if this guy is there in the company, then only he will give the project. If this guy goes to another company, so that this company will approach that company only. This client will approach that company because this client believes on him only. So if he goes to another company, if he says, okay, next project I will complete in 6 months, this is the budget. So he will give that blindly. He will give that project to that company. So company will get the project from these guys only. Company will get the project from these guys only, that architect engineers. Okay, but to work as an architect engineer, you need a lot of experience. You need a lot of experience. So minimum you need 10 years of experience in the programming, and you should go through all the phases of project development. You should go all the phases of project development. Like you should know the program. You should work as a developer. You should work as a testing engineer. You should work as a validation engineer. You should work as a debugger. After delivering the project, also maintenance. In the maintenance side, also you should work. Then you should have the experience about the maintenance. You should have the experience about the you should have the experience about the quality and testing, right? Q&T we say. So you should have that experience also. So minimum 10 years of experience, this much skills are required, and those many skills are required. Then you can work as a architect engineer. But work pressure will be more. Okay, believe me that one. Work pressure will be more, but salary also they will give in that way only. So I saw one of the person's salary is, if you can see in the circle, I saw one of the person's salary up to this one. So there is a company called as a Redeem Software. So in that one, the guy was working as an architect engineer. He was getting this much of package. So just imagine. But workload will be good. No, it is not like that. Testing is good or development is good. It is not like that. All need skills. All need skills. Development also need a skills. If you are working as a developer, you need a development skills. If you are working as a testing engineer, you need a testing skills. And believe me, So after development in the companies after development, the next stage in the project, next stage will be testing. So some of the group of peoples will be working in under the development stage. So group of peoples will be working under the testing stage. So if until unless testing team will not tell that this code is bug free. If the code is bug free, then only they will give it for quality and testing purpose. This is Q team will be there, right? Quality and what is that QA team will be there. So they will check the quality of the project. But testing team has to approve that one. Testing team has to approve that. And if the testing team is not approving, there is a bug in the project. So then testing engineer can make these developers cry. These developers will not sleep for a night like they will not sleep for many nights. If the tester says, okay, if there is a bug in the project. So if there is a bug in the project, like you should complete that one. So yeah, tester knowledge should be more than the developer. It is not like that. Okay, many people's like some peoples are misguiding the students, misguiding our students. Like testing development has more demand, testing has more demand. Like that, they are doing it, and they're actually like some of the students they're actually believing on them and they're rejecting the company. And after few years, they are telling like few years the guy who selected testing or development, they're going to some other level, and the guy who listened to that senior, they will be there only. Okay, so it will be like that. Okay, so okay, now it is not like that going in the detail like quality team and all this thing. They will like you will come to know when you get into the company. Okay, so that is what is the like positions will be there in the company. So after completing this device driver position, like once you complete this device driver position, if you want to stay in the embedded domain only, so once you get bored with this device driver and firmware engineer, then at last you can try for board support packages, board BSP as a BSP programmer or BSP testing engineer positions will be there. BSP testing engineer position will be there. You need all this knowledge, including hardware knowledge. You must be perfect in the hardware. If you want to work as a BSP programmer, board support packages programmer, you must be perfect in the C language, microcontroller, protocol, Linux, hardware, and somewhat mathematics also. So anyhow, math is common here, right? Like when you want to develop the algorithm, math is common here. So if you want to work as a BSP programmer, you need all this knowledge, C, microcontroller, protocol, and Linux, and you need a strong knowledge of my hardware. Okay, if you are actually good in the PCB designing, if you are good in the knowing like what resistor, capacitor, and all these diodes and all these things are doing it, so then you can work as a BSP programmer also, and you will get compared to device driver, you will get more package and you will get very good companies also. Like after completing the BSP, you may get you will get a chance directly into an Intel, directly working for Intel, not through any company. So you get a chance into the Samsung company also, Samsung company, Intel company, Motorola company, Sony company. So the chip designing companies are there, right? There you will get a chance to work as a BSP programmer. Okay. So that is the last stage I can say. That is the last stage in the embedded system, I will say. Okay. So after getting into the company, maybe you will come to know like many other ways. But I would say like according to my knowledge, the BSP, like if you go in the BSP, you can settle down in the BSP only. Okay. It is not that much calculus is required for embedded system. Like till now, like no student said I have used derivatives and integrations into the mathematics. Simple mathematics is enough. If you are good in that simple mathematics, that is enough. That much math, that level it is not required. If you are a genius, if you are very good in the mathematics, then you should try for R&D departments. You should try for any company R&D departments like DRDO, NASA. This side you should try if you're good in the mathematics. Okay. Otherwise, like if you're like okay in the mathematics, like 80 KT, then 40%, like only 40 enough, only that in that level also it is okay. Okay. That's okay. Like this is what you should do it. Okay. Your focus should be clear. Like I said about embedded engineers. Okay. Like for software engineers, like the position will be like that only, software developer, and you will become a team leader. After that, you will go to the manager position and all. Okay, so if you want to be as a programmer in the embedded system, so first you try firmware engineering, then you try device driver. You work for 5 6 years or 10 years. You work as a firmware engineer. After that, you go to device driver. After that, you go to BSP. At least you have to spend 25 30 years into the company, right? So you should not get bored with this one. Like if you're doing firmware engineer again and again, you will get bored after some time, after some years. So then you switch it, something new, something challenging. So you will get bored after a few years. Then you go to BSP, something new, something challenging. So by that time you get bored, you will get retired. Okay. So that's what you tried. That's what you tried. Okay. So this is what is the focus you have to keep it. So like this is for embedded engineers. Whatever I know, like I said about the embedded engineers. So hope this will be helpful for you. Okay. No, without gate, I don't think so. Like it is possible for DRDO, ISRO, and this thing. I don't think so. Like there are direct exam will be there. You have to check it out if it is there or not. Because I have seen some student where our students only got selected for DRDO as a training engineers. So actually they have given exam before coming to Vector, and after that they will get an apprenticeship. They will do it for like as a training engineer. They will join it in the DRDO and all. Okay. So job in Intel, like see, first of all, I will tell you, Intel will not hire the students from Intel will not go to any institutes kind of thing. Okay, it is not going to any institute in India. They will directly go to IIT and they will directly pick the students from there. So my suggestion is, if you actually going through this way, like suppose if you're having the marks like a 60 or 70%, so what you do is you get experience for like 5 6 years experience, you get it and try to apply for Intel, or maybe you will get a chance to work into Intel as a client location will be there. Okay, what company will do is, so you are here right now. So one company, X company will hire you. Okay, and this company will send you to the client location for project. Okay, so client can be Intel also. This client can be Intel. So if we get into like client can be Intel, client can be Robert Bosch, like this they will send it. Okay, if this project is Intel project is completed, then this company will send you to another company. Okay, here is the project requirement, you should go to this company. So this project is completed, again the project is from Intel, again they will send you to Intel. Okay, now assume that there is a requirement, there is a software is there, and that software actually in India no one knows, and so the company wants to train you for that software. So sometimes they will send you to some abroad also. Sometimes they will send you to abroad also. Okay, so where is the main branch will be there, right? That company, this company will send you to abroad. So there you have to work for 1 or 2 months. Again you have to come back, and then they will send you to client location again. Okay, so this type of companies are called as a service-based companies, and there are a lot of service-based companies are there in the India. Lot of service-based companies are there in the India. So Intel is product-based company, Bosch is product-based company. So once you get placed into the Intel or Bosch, this Intel company will not send you anywhere because it's a product-based company. Okay, and the company which is sending you to another client location, that is called as a service-based company. Okay, so both are good. Okay, don't ask me which one is good, like service-based company or product-based company. Both are good. Both package almost will be same. But if you get into the branded company, the package will be more. If you get into the branded company, package will be more. Don't think that Bosch is very brand company, he will give good package. He is starting, sometimes it will give 3 lakh or 4 lakh package only, Bosch. Okay, don't think that, okay, Bosch is a branded company, it will give very good package. It is not like that. They will start package from 3 lakh or 4 lakh like that for the fresher. So this may happen. This may happen in the companies. Okay. So like you have to upgrade yourself always. Always you have to upgrade yourself. Suppose if the Intel project is on C++, then the client, while recruiting you, they will actually confirm whether you are good in the C++ or not, or C or not. So if you are good in the C++, then this company, X company will tell you, okay, there is a project on C++, go to this company, go to the client. They won't listen you, like you are not comfortable, I'm not comfortable, I haven't worked. They won't listen you because they have hired, they will send it here. So you have to learn the C++ and you have to start working on the project and you have to complete it. So again, you have to come back. Again, the Bosch is giving project on C language, then they will send it to you only, this one only. So you have to do project on C language. Sometimes actually there are some companies for electronics engineer, they will give Java also. There are some companies they will give Java work also. They will actually conduct interview on C++, and they will give the work on the Java also. Okay. So I have seen there are some companies, they will give it. Okay. Yeah, in embedded companies also there are chances to go on site. There are embedded companies that go chances to on site. Like last time Methodo Electronics I said, right? So that Methodo Electronics they are giving, still now they are giving, after 2 years also they are giving 5 lakh package, but they have given a lot of on site opportunities to that employee. So I already said that Methodo Electronics very like the company actually, he is working as an embedded engineer only. So far he has visited around 7 countries. In 7 different countries he visited for learning that hardware things and software, all these things. Okay. So far in the vector, highest package for fresher is 15 lakhs, 1.5 starting package. So far in the vector, highest package is 15 lakhs, and that is given by the SanDisk and analog devices. So far in the vector, highest package is 15 lakhs given by the SanDisk and analog devices. So this analog devices has given like approximate 2 lakh joining bonus also. This analog devices has given 2 lakh joining bonus also. Yeah, actually our students are working into SanDisk company. Okay, our students, many students are working for SanDisk company. Magneti Marelli is also there. I think it is Ahmedabad side. Magneti Marelli. They're working on embedded side only. So like I cannot tell you like package of all the companies. So we can remember the highest package and lowest package. Okay, that only 2 things we can remember. It is not like there are hundreds of companies are coming. Okay, it is not possible to remember all the details. Okay. Yeah, on-site, obviously on-site, if you're going on-site, package is going to increase. Okay, this is not training and placement class. Please continue for our here. So embedded system, like it's a combination hardware, software, so that we discuss. Okay, now come back to our topic here. So hardware used inside this project, digital clock project, is microcontroller. Microcontroller, and along with that, some switches are used and RTC is used and displays used. Okay, so we'll keep it as a microcontroller as a hardware. And the software which is used is written in the embedded C. Let us write down, or I will write it as a C language. Software which is used is called as a that is called as a C language. Okay, so you can see this is the project of combination of hardware and software. So we have a hardware here, and we have a software here. Whatever the program we write is called as a software. Okay, usually see we are a programmer. So whatever the program we written in C language, C++, Java, .NET, whatever it is, whatever language you use it, that we call it as a program. But for non-technical peoples, that program is nothing but an software. For non-technical people, that program is nothing but an software. Okay, there is something software is there. Okay, so we say something is software. So we used to tell there is a program. That is the software. We used to tell there is a program. Okay, so. Yeah, actually, there is the reason behind using the C language is why C language mainly used in the microcontroller. That's a good question. So when you write a C program, when you write a C program, let's go. So when you write a C program, when you compile your program, you have to do cross compilation. You have to do the cross compilation. If you write C++, embedded C++ also, you have to do cross compilation. You will get the hex file over here. You will get the hex file. So what happened is when you use the C++ program, the hex file size of the C++ will be having the more size. The size of the hex file, when you compile the embedded C++ program, the size of the hex file will be greater than the size of the C hex file. So when you go to the microcontroller, you should be knowing it. Like later on we are going to discuss that one. Inside microcontroller, you will be getting a small memory. You will be getting a small memory to store this hex file. This hex file is nothing but your compiled program. This hex file is nothing but compiled, and we have to store this hex file contents into the memory. So this memory is limited. This memory is limited in the microcontroller. Suppose if you are using C++ program, you've done the same project using C++ and C language, and if the hex file size is greater than the given memory of microcontroller, then the hex file of C++ cannot be stored into the microcontroller memory, right? So only C language hex file can be stored. So when you compile the program, the hex file size will be very, very small. Hex file size will be very, very small. Okay. So if you are using the C++ simple program also, if you do it, the hex file size becomes more. And that's the reason actually C language is selected for embedded system. C language is selected for embedded system. Okay. And I know there are in the C++, there are many more features are given. There C++ has more features than C language, but still the companies are selecting C language. It is because of the limited memory space available in the microcontroller. So in the microcontroller, you will never get the GBs of space, or you will not even get MBs of space. You will not given even MBs of space. You will get a space, memory space in the KBs, kilobytes. You will not get in the megabytes or gigabytes also. Okay, so that's why the hex file size should be smaller, and that is possible with the help of C language only. That not possible with the C++. Okay. Yeah, when compared to all of them, like C++, Java, or .NET, compared to all of them, the C language hex file size for the C language will be smaller than all other. Okay. No, actually, what is the size of memory size in microcontroller? That changes from controller to controller. That changes from controller to controller. Like, okay, so when I come to that microcontroller programming, I will tell you what is the size. Okay, in the 8051, it is 4 KB. Let us assume that. In the 8051, it is 4 KB only. So when you change the controller, the size of memory will increase. Okay, now check it out. In this embedded project, whatever the digital clock we discussed. For example, I have taken this digital clock as a reference. So in the microcontroller, this one, as a hardware, you can use microcontroller. Microcontroller is there, and some other hardwares. Other hardwares used in the project is switches. Switches is also hardware, right? Display is also hardware, and real-time clock, etc. Real-time clock, etc. So microcontroller is the main hardware used in the digital clock project, and other hardware are switches, displays, RTC, and sometimes you will get LEDs also. LEDs also sometimes you will get inside the digital clock project. Okay, digital clock has only LED, right? If you want to, in the night time, if you want to see the time, there will be a button. When you press that button, when you press that switch, the light will on, and you can see the time in the night time also. Okay, so that is what is the digital clock project. This is the hardware and this is the software. This is the hardware and this is the software. Okay, so as a programmer, we will always call it as a program only. We will not call it as a software. But most of the time, non-technical people will call it as a software. Okay, and actually it is a software only. But we programmer has a habit of calling it as a program. That's why we say it as a program only. Okay, everything like whatever now Notepad, whatever the Notepad is there, right? People used to call it as a software only, Notepad software. But actually, Notepad is a program which is displaying the GUI, which is actually scanning the characters from end user. It is like a terminal. It is like your terminal only. It is like your terminal. Terminal is scanning the character. It is giving that, echoing the character. That is what is the Notepad software. Okay. So, but Notepad is the program which is displaying the GUI, which is scanning the character, and which is displaying the same character whatever you are typing on the keyboard. Whatever character you are typing on the keyboard, Notepad will read it. It will read it, and it will display the same character on the same place. Okay. So that is what is the Notepad software. It is a program only. Okay. So I hope you are understanding this hardware and software. It's a combination of hardware and software. So only hardware is not sufficient in the embedded system, and only software is not sufficient in the embedded system. Okay, and one more point is when you get placed as an embedded engineer in the companies, the companies will not ask you to, design the PCB or, solder out some resistors, solder out some capacitors, solder out some diodes or triodes and all these things. When you get placed as an embedded engineer, you will get a work to write a program only. You'll get a work to write a program. Sometimes there are some companies, they won't show the hardware also. They will only give the requirement. They will give the requirement and they will tell you to write the software. That's it. The hardware will be at one place only, like somewhere in the same country or some other country or some other city will be there. So they will ask you to write a program. And when you write a program, when you write a logic, some other guy will other guy will compile that program. And that guy will download that program into the microcontroller. Then there they will check the output. If output is not correct, again they will tell, okay, there is a bug, and then again the same bug will come to you. It will be assigned to you, and you have to find out that bug and you have to solve that bug. So most of the time, this is what happening in the companies. Okay. So if you're working into multinational companies, like Robert Bosch, Intel, and all these things, sometimes you will not be, as an embedded engineer, you will not be able to see the hardware also. Sometimes you will not see the hardware. But if you're working into the small scale company, if you work into small scale company, the hardware will be in front of you only. Hardware will be in front of you. That is the benefit of the small scale company. Okay, I won't say like Robert Bosch or Intel. I'm not targeting these companies, and it is not in all the cases. It will not happen. Okay, So when you get into the multinational company, sometimes if you are actually, if like sometimes the company policy, what they will do is they will give the hardware to embedded engineer. They will tell you to write a program here, then flash that program into the controller, or that download the program into the controller and check the output on the hardware itself. So this type of work is also there in the companies, okay, multinational companies. But some of the companies will not show you the hardware. So like most of the time you have to play with the software only. Most of the time you have to play with the software. So once you get placed as an embedded engineer, so like most of the time you have to play with the software, not with the hardware. So for hardware, like suppose if the hardware is not giving the output, then hardware team will be different. There is a different team they will hire for hardware development. So that team will take care of the hardware. If any problem with the hardware, testing of hardware, all these things that is taken care by the hardware engineer. But software engineer, you should only take care about the software. Okay. So that means like straightforward, I would like to tell. So when you get into the company as an embedded engineer, you will get the ready-made hardware for users. So company will not ask you to design the hardware or design the solder out some components or all these things. Maybe sometimes you will get a work on breadboard. So they will tell, okay, there is an extra sensor, you have to connect it. So use the breadboard, connect the sensor on the breadboard and test it. So sometimes you should know like how to connect that wires. You should know that one. Okay. Okay, and in the vector also, we will not teach you how to do the PCB designing, how to solder out these components, all these things we will not discuss here. Okay, not online classes, not offline classes even. Okay, so we teach like we used to give like what we used to do in the practice session is, so in the practical session, when the students are coming to lab, we used to give one microcontroller board to the student. For practicing, we used to give one microcontroller board to the student. So for one student, we used to give one board. Okay, so student used to practice on that hardware. Student used to practice on that microcontroller board, and while going, they used to submit the board. Next time you come again, we will give the board. You practice it in the lab itself and return the board like that. So for every student, we used to give one microcontroller board. Same board will be there. So that is designed by the vector only. So whatever the board is designed by the vector, the same board we used to give it to the students. Okay. Like how or where we can buy this board. Okay, for vector board, actually what happened is due to lockdown, these people are not working in the vector and nobody is there to dispatch the board. So right now it is started, like front office team is there in the vector in the office, but actually the guy who actually designed that PCB and the guy who dispatched the board, that guy itself is not available. He is doing work from home. Okay, so that's why as of now we are not I'm not having any news regarding like sending boards to the students. Okay, so if you want to buy the board, you buy it from some another site. I already told you, like yesterday some student has sent mail and already have revert back to them. Okay, so you can also buy board online also, and as I said, you will get the refund up to 1,000 rupees. Okay, not up to 1,000, flat 1,000 rupees refund we will give it. Whatever the board cost, we will give the flat 1,000 rupees. Okay. Which C concept is mainly required for embedded programming? All concepts of C language required for embedded system programming. Okay. Don't ask me that one. Okay, I get angry with that question, because if I tell you that topic to concentrate in the embedded system, then you will concentrate only those topics, and then you will get stuck actually. In the interview, if they ask you something different, then you will get stuck. Okay, and you will lose the good opportunities. Okay. So my suggestion is, do not skip any topic in the C language. Do not skip any topic in the microcontroller. Okay, don't target the topics. Like there are actually many students from BE7, they have sent the mail. Tell me some important topics because now we are getting a burden. Don't do that way. Okay, from day one you start working on it. Maybe you will get a chance to work as a software engineer. You may get a chance to work as an embedded engineer, device driver engineer, RTOS engineer. You will get a chance. Okay, so don't lose that one. Don't lose that opportunity. So this is about the embedded system combination of hardware and software. This is what we discussed, okay, with the help of the digital clock. Almost in everywhere, like if you take example of washing machine also, you will get a microcontroller, then switches and displays and LEDs will be there, okay. Then RTC will be there for counting the time. So there also it will be used. Like there are some other devices like in the washing machine. If you take example of washing machine microcontroller will be there, right? Whatever the control panel will be there on the washing machine, like only switches will be there. So switches will be there. Then you will get 7-segment display. You will get the 7-segment display, and as well as like LCD displays are also available. 7 segment or LCD display, you will get it on the washing machine. So you will get the RTC also, you will get the LED also, you will get the buzzer also, and you will get the buzzer and you will get the WPROM. You will get the WPROM also. Okay, this microcontroller is common. Microcontroller is common, and these extra things you will get into the washing machine. For rotation of high voltage motors are used. Yeah, like motors are used. Obviously, motors are used. So I forget about the motor. Motors are used. Very high voltage motors are used in the washing machine. So this is about the, see, microcontroller is common. So what you should do is you have to write a program for microcontroller. Let us take a example of printer also. In the printer also, you will have a microcontroller. In the printer also, you will have a microcontroller. There are actually many companies, they are working on the printer project. One of the company recently came as a Toshiba company. Recently that student got the company as a Toshiba. In the Toshiba company also, they are working on the printer project. They are working on the printer project, and they actually hired students from Vector only. So in the printer also, they are using a microcontroller only. Printer also they are using a microcontroller. Okay, so like USB protocol that will be used in the printers. So protocol, I said like protocol, right? So for printer, USB protocol is used to connect the printer with computer. Okay. So this is what is called as an embedded system, hardware and software designed for the specific designed to perform a specific task. Okay, this is what is the embedded system. Now, the benefit of learning the C language, like if you haven't started C language, or you haven't like if you're not good in the C language, remember, if you're good in the C language, you can understand embedded C very well. You can do embedded C programming very well. You can do embedded C++ programming very well. Embedded C++ programming very well. You can do embedded Linux programming very well. You can do embedded Python programming very well. Okay, if you know C language, then you can go this side also, embedded side. You can go to embedded side. And if you're good in C language, you can go to software side also. You will become perfect in C++, Linux programming. You will understand Java programming also, like those who learn Java, those are from CSC background. Once you understand C++ in detail, so you will understand Java programming, .NET programming, and etc. So you will understand Python and other scripting languages. Other scripting also. So if you are good in the C language, like you will get like very much good scope in the industries. You can go to software side, you can go to embedded side also. That's why the C is common here. So if you haven't started C language yet, or if you're not recommended, you are getting fear to work on C language, I would suggest, if you're having fear about C language, like you're not understanding pointers, you're not understanding this pointers and all these functions and all, I would suggest practice 10 hours daily. I would suggest practice 10 hours daily. You practice for 15 days continuously and just see the magic. You will enjoy like anything. You will enjoy like anything. Okay, those CSC students actually, they are actually learning from many years. For them, C language is not that much difficult. They knows very well. But for embedded students, electronics and electric students, for C language is one of the challenging thing. Okay, so if you are feeling it is a challenging, then I would suggest you practice daily 10 hours and see the magic. After 15 days, you see the magic. You will enjoy C language. And just what you do is, when you learn the C language, what are the programs given in the classroom, you do it. And you just think it. You just imagine, okay, like what if I do like this? What if I do like that? Can I write the program like this? You just imagine and try to put that imagination into the program. Just try to put that imagination into the program. It is like a magical thing you are doing it. You're just doing it the magical thing. Okay, that is what is the programming world is. Okay. Not only DC motors are used in the microcontroller. Why DC motors are used in the microcontroller? You can actually control that AC motors also. What are the three-stage what are that motors are used, right, in the AC motors, that also you can control it, but you cannot control the AC motors directly. 3-phase motor, 1-phase motor, you cannot control directly. So with the help of relays, you can control that 3-stage motor and 4-stage motor. Not converter. Only you need a relay. You need a relay only. Okay, like brushless, actually BLDC motors and DC motors almost like the programming is almost same only. Okay, like BLDC motor, the programming is almost same only. So AC and DC motors you can control with the help of microcontroller. DC motors you can control directly, but if you want to control the AC motor like single phase or three phase motor, then you have to control through relay. And relay programming is same as like your IO programming only. It is not that difficult. So don't worry about that one. Okay, that is like almost simple only. Okay. So once you good in the C language, you can go to embedded side and software side. Both will be helpful. Both side will be helpful. Okay. Okay, now in the embedded system, there is a role of microcontroller. There is a role of microcontroller. Okay, almost in all embedded systems, microcontrollers are used. Almost all embedded. Let us take example of washing machine that control panel, AC control panel, remote control. Remote control is also embedded device. Okay, in mobile phone also you are having microcontroller, not microprocessor. In mobile phone also you are having microcontroller, not processor. Then we have a smart watch nowadays. We have a smart TV, routers. We are having like I'm using this USB to Ethernet converter. USB to Ethernet converter also example of embedded device only. Okay. Brushless motor, we will not take the class for brushless motor. Okay, that motors we will discuss, but not for brushless motors. So we will teach you like how to interface the motor, but not brushless motor. So once you understand DC motor, you will understand that programming also about brushless motor. It is not that difficult. Okay, it is not that difficult. Don't worry about it. Okay. So this USB to Ethernet converter also it is an example of embedded system. USB to Ethernet converter is also example of embedded system. Okay, another example is Geo Wi-Fi router. See, Geo Wi-Fi router is also example of embedded system. It's actually this is actually networking based embedded system. It is a networking based embedded system. If you open the Geo router, inside the Geo router you will get microcontroller only. You will get the microcontroller only. Okay, so there you have to learn the TCP/IP, all these things and all that things you have to learn it. Okay. So this is what is embedded system, and we use microcontroller in all the embedded systems. So don't think that embedded systems like only washing machine and AC and this thing. You have to tell example of router also. You tell the example of router also. You tell the example of USB to Ethernet converter also. This USB to Ethernet converter is also one of the example of your embedded system. See, this is the open one. This is the pack one, and this is the open one. This is the open one, right? You see there is a microcontroller on the board. You see there is a microcontroller on the board. There is, I think I see the microchip symbol. I see the microchip symbol. Yeah, here it is. You see, here is the microchip symbol. They have given the microchip microcontroller, which is taking USB packets and it is converting to Ethernet packet and it is sending it. So it will take Ethernet packet, it will convert to USB packet and send it. Okay, like that. It is like a converter, like Chinese to English, Chinese to English, English to Chinese, like that. It's a converter. So USB packet is coming, it is converting to Ethernet and sending it. Ethernet packet is coming, converting to USB packet and sending it. Like it is like it is like a mediator, language mediator, right? Chinese to English, English to Chinese, Chinese to English, English to Chinese, like that. So here is inside this there is a program. Inside there is a program, and this is nothing but an embedded system. This is nothing but an embedded system. Okay. So like it is not only like electronic toys and all these things are example of embedded system. So these are other examples also there. Okay. So please check it out and please answer this thing. Remember this and explain it in the interview. Okay. Yeah, in the embedded system, Ethernet protocol is used. In the embedded system, Ethernet protocol is used. See, like inside the car nowadays, if you are going for the, I will search car. That is called as a EBD. Car OBD port, not EBD port. Car OBD port. Inside the car, you will get this type of port, right? You get this type of port. So what will happen is nowadays, when you're going to car servicing also, there also like you will get an example of embedded system. So nowadays, if you're going for car servicing, so what they're doing is the engineer will come and they will connect one cable over here. They will connect one cable over here, okay? And they will connect this cable. That port will be like under the steering. Under steering, see here they have given it. So this is the steering, and under the this one steering, there will be a port that is called as the OBD port. Okay. So what they will do is they will connect one cable from here and they will connect it to laptop. So they will connect it to laptop. So they will connect it to laptop means they have to connect it to Ethernet port only. They will connect it. They will connect one end will be OBD port and second side will be it is a Ethernet port. So this is one of the example of embedded system. So there will be a laptop or desktop. They will connect it. So in the this is car actually inside the car. This is what is called as the embedded system only, right? So like horn, then there are switches will be there to open and close the window. Switches will be there to like move the wiper. Switches will be there to turn on and turn off the indicator. So that is embedded system only. Okay. And nowadays in the cars also they are using this Ethernet port, OBD to Ethernet port for diagnostic purpose. For diagnostic purpose they are using this port. Okay. So there also like it will start. And actually there is a OBD tool coming into the market. And that OBD tool is an example of embedded system. OBD tool is an example of embedded system. OBD tool, OBD scanner software, not onboard diagnostic here. Like this type of diagnostic tool, you will get it into the market. Like this type of diagnostic tool, you will get into the market. Okay, like this. So this is one of the example of embedded system. So what they will do is they will check the errors. Why this OBD tool is used? They will check the errors. That is called as the onboard diagnostic. So whenever you connect this, when you connect this tool to the car, so what will do is car will send the list of errors. Car will send the list of errors. Now no need to no need to drive the car when you're going to, like if you have ever visited the car service center. So if you go to car service center, now that engineers, the mechanic is not driving the car. They will not drive the car. What they will do is they will use this OBD tool and they will connect it to car, and car will send the list of errors to this tool. This is what is the CAN protocol, that is actually related to the CAN protocol. Isn't it interesting? So car will send the list of errors here. So here you will get the list of errors, and then the mechanic will understand, okay, they will get the numbers. Okay, this number is for steering related issue. That number is for engine related issue. That number is for mileage related issue. Like that numbers you will get it. Errors will get into this tool, and then mechanic will solve that error. And after solving that problem, again they will connect the tool. And if they are getting 0 errors from the car, that means car is serviced. And then they will give the call. You can take your car like that. Okay. Yeah, if actually lights are coming means it is a type of error. Like, yeah, it can be a dashboard. Some lights are coming means actually something like that is for engine temperature. Actually, engine temperature, when the engine temperature is more, so on the dashboard one LED will blink. So that what you should do is you have to stop your car and open the bonnet. You have to open the bonnet and keep open for 10-15 minutes. Then the engine will cool down. Then you can actually continue the car. Okay. So that is one type of error only. That is one type of embedded system only. That is one type of embedded system, right? So read the temperature using temperature sensor and blink the LED. That is one type of embedded system doing a specific task. Okay. So this also example of embedded system, OBD tool. OBD tool is also an example of embedded system. See, your embedded system example is not like a washing machine or electric oven or electronic toys or this one like mobile phone or digital clock. These are also tools are there, right? OBD tool I said about the USB to Ethernet converter I said. So like this also. Okay, so router is there. Whatever the router you are using at home, whatever the Airtel router, Jio router, whatever the router you are using, that is also example of embedded system. Inside router, you will not have the microprocessor. You will get a microcontroller inside that. Okay, so please check it out. In the router also microcontrollers are used. Okay, so this is also embedded system. Like ticket machine, ticket tool. Let's see. Ticket printing. Buses. See, this is ticket printing machine is also example of embedded system, right? It is a wireless, it is an embedded example only. See here, ticket printing machine. So like this, like inside the car, whatever the button pressed, window open, button press, window close, button press, door open, button press, door close in the in the buses. So that is example of embedded system. You should tell that example also. Okay. So don't tell only like that one. Like whatever surrounding you see, like when you sit in the interview cabin, you see the surroundings. Whatever there, you can tell the example. Except computer and laptop, remaining all are embedded systems. Except computer and laptop, remaining all are embedded systems. Okay. So today I think we had only discussion on embedded system. Yeah, digital thermal scanner. Nowadays this is getting more popular, right? Oximeter. Yeah. Now this is getting more popular. Oximeter is one of the example of embedded system. Yeah, thermal scanner. This is everywhere now. People are using, right? Thermal scanner machine. See, this is also example of embedded system. Okay, in the COVID only people come to know there is a something called as a oximeter. So AccuCheck, actually this is actually checking the sugar level. It is checking the sugar level in the body. This is also example of embedded system. This is also example of embedded system. Okay, so embedded system is already there in the medical side. It is there in the automotive side. It is there in the avionics side. In aeroplanes also it is used. It is there in the domestic side. In home also we use digital clock. We use electric oven. We use. So that is also example of embedded system. Okay. So like this, these are all these example of embedded systems. Okay. So you should tell these points. Like today's date, like this COVID is like it is there, right? We are actually in the situation like where everyone is using this, this oximeter and thermal scanner. All these things we are using it, right? You can tell this as an example. So this is what is an example of embedded system. You see, there is a microcontroller, there is a display, there is a sensor. There is a microcontroller, display, sensor. So we put a finger here and that sensor will check the O2 level and it will convert that O2 level into the number and that number will get printed on the screen. That number gets printed on the screen. And we make sure that when you are actually working on medical projects, medical side project, your output should be accurate. 100%, it should be 99.9% should be accurate. Okay. If it is wrong, you should know that one, what will happen. Suppose instead of 99, if it is showing 79 level, oxygen level, then in the hospital also no one will take in today's date. Hospital also no one will take. So be careful when you're working for the medical side. If you're working for AC side, suppose you're working on AC project, and suppose you set the temperature as 30, and you are displaying 32 temperature, there is no problem at all in AC. If you're displaying 32 degree temperature on the AC, there is no problem. But actual temperature set is 30. But it is printing 32. There is no problem at all. But here, if it is 99, your O2 level is 99, and if it is displaying 79, no hospital will also take you in the hospital without a COVID test. Okay, today's date. That is actually I'm taking it a joke, but it's very serious matter today's date. So like that. Suppose on washing machine you set the program, and washing machine is showing 60 minutes. Washing machine is showing 60 minutes, and within 50 minutes only, washing machine completed the program. So there will be no problem. See, 60 minutes short, but 50 minutes completed. Who is watching there? Like who is taking the time? Who is checking the time for that washing machine? Right? If it is completed, if the program is executed within 50 minutes, that is enough. Okay, so people won't bother about it. So this is what is the example of the embedded system. We saw some real-time example today. What is embedded system? What is hardware? What is software inside embedded system? I think tomorrow only we will start the difference between microcontroller and processor. So today we will wind up our session here, and in the next session we will continue our discussion. Thank you guys for attending virtual classes. See you in the next session.